Area of a triangle. As you see here, we have a theorem for an area of a triangle. And we have these formulas here. I would encourage you to have this out to the side when you work on this section. The area of a triangle is given by the area is equal to half of b times c sine alpha. And if you notice, we got BC here, so we have alpha. We got AC, so we got beta. We got BA, or we got AB, and we got gamma. So if that helps you memorize that, I would encourage it. However, I would have it out to the side until you do have it memorized. Here is a visual diagram of the triangle representing. We got side C, B, we got the angle alpha, and then the H, height. That's an example of the first one here. The Heron's area formula. The area of a triangle with sides ABC is given by the formula of A is equal to this. And then where C is equal to this. And let's just have this so when we get started, and let's just jump in here and do some examples. So on the first one, it says find the area of a triangle with the given parts. We're giving a degree of alpha, B, and A. So we got sides B and A. So knowing this, we can say, okay, well, let's solve for, it says find the area of the triangles for units. All right, so we're going to find the area of the triangle given that the formula that we have shown above, where A, B, C are all sides of the triangle, alpha, beta, and gamma are all the angles of the opposites of these sides. So it's helpful if you was to draw a picture and label, especially if you're a visual person. And when you draw it, you're going to notice that the sides A and B are given here, right? Because when we go label, we notice we got alpha as the angle and then the two sides B and A. So we want to use the formula A equals half AB sine of gamma. Okay, unable to solve for this formula because we don't know what gamma is, right? Remember, C is the unknown. So in order to find gamma indirectly by first using the law of sines to find the measures of beta, let's find it, okay? So if I'm looking for beta, I got sine of beta over B is equal to, and let's use what we do know. We have alpha and we have A. Sine of alpha over A. Now let's solve for beta, sine of beta, so I have to multiply both sides by the denominator in order to undo the fraction. So I got sine of beta is equal to B sine of alpha over A. And since we want beta, let's take the inverse of sine. All right. So now that I got all this, what I'm going to do is I'm going to go over here and let's fill it in. All right, B is 16.6, sine of alpha, alpha is 38.5 degrees, all divided by A is 17.4 degrees, or not degrees, it's just 17.4. Okay, when I type this in my calculator, round to the nearest tenths, I get 36.4 degrees for beta. So we're doing good. So now we know two angles, right? So knowing two angles, I can solve for the gamma, right? I can say alpha plus beta plus gamma is equal to 180 degrees. Solve for gamma, get gamma is equal to 180 degrees minus that alpha, minus that beta. Plug in what we know. Alpha is 38.5 degrees and beta is 36.4 degrees. And when we subtract these, we get degrees of 105.1 degrees. Now that I've done that, I can go up there and say, okay, the area is equal to half of A. A is going to be 17.4 times B, which is 16.6. Sine of gamma, gamma is 105.1 degrees. We're going to type this in our calculator, round to the nearest tenths, and what we're going to find is we get an area of 130, well, approximately, because remember we rounded, approximately 139.4 square units. All right, let's solve our next one. The next one says use the Heron's formula to find the area of the triangle with the given sides. So when we do that, we know the formula because it was given to us from above. We got the area is equal to capital S times S minus A times S minus B times S minus C. And it's all capital S, but A, B, and C are lowercase. And we know that capital S is equal to A plus B plus C, all divided by 2. All right. So what do we have here? We have A, B, and C. So we can just plug it all in, right? And we have that worked out. Well, first I need to figure out what S is. So let's plug in for S. We got 4.8 plus 8.9 plus 11.1, all divided by 2. Okay, so now let's add it all up. We get 24.8 divided by 2. And when I divide it by 2, I get 12.4. Now no S. So I'm going to plug in everywhere S is 12.4. 12.4 minus A times 12.4 minus that B times 12.4 minus that C. All right. And now let's go ahead and clean it up. So I got 12.4 times 7.6 because I'm going to go ahead and subtract. I'm going to do it in steps. Some of you won't, some of you will. That's fine. Just watch your numbers. So now when I multiply this all together, I get 428.792. And when I take the square root of it, when I round to the nearest tenths, I get 20.7. So that is the area using the formula of Heron. All right, so now let's go to our next one. So a surveyor locating the corners of a triangle piece of property started at one corner and walked 480 feet in the direction of north 34 degrees west to reach the next corner. The surveyor turned and walked south 18 degrees west to get to the next corner of the property. Finally, the surveyor walked in the direction of north 81 degrees east to get back to the starting point. He wants to know what is the area of the property in square feet. So I would encourage you to draw the picture to help you. The bearing of a ray is the acute angle the ray makes with a ray pointing. So whenever we're drawing, so it said northwest. So a ray means we're just going to put a triangle showing that it's going in that direction. And from there, it's going southwest. And then from here, it went northeast. See that? My drawing's not perfect, but it ends up making this angle, right? This triangle. All right. We're going to let A represent the starting point of the surveyor. So right here's A. And then we're going to say B represents the second corner. And then C. And this should came out more right there. C. All right. Now we're going to have A, B, C. All right. We're going to take the whole area of that. From drawing this, we observed. Now, this statement here, if you're wondering what it means, it just means the measure, right? We're observing the measure of the area to B, right, for B in the sum. If we go back up here to where it's asking, it says the area or the measure for B, we know that we got, let me highlight it right here in our application file. We got 34 and 18, right? Notice. Okay, so what I'm going to do is take that 34 degrees plus the 18 degrees and add it up, and I get 49 degrees. Now we're going to take the measure for C. Well, we notice, what do we got here? We got 81 and we got 18. So we got 81 and then we go back to 18. So we're not going to add those, we're going to subtract them because that's a difference of them. So 81 minus the 18 gives me 63 degrees. So note that the sum of the angles of the triangle is 180 degrees. So when we talk about triangle, we know it's a sum of 180 degrees. I'm going to just do a little notation. We got a measure of A. This is telling me that the whole entire triangle is 180 degrees. We're going to subtract it from the measure of B. Actually, let's stop for a second. Let's just start all over. So that way you can get a better understand what I'm saying. When we talk about a triangle, we know it's a total of 180 degrees. That means we're going to take the measure of A plus measure of B plus the measure of C. They all three add up to give me 180 degrees, but we don't know the measure of A, right? We know the measure of B and C. So I'm going to subtract these and to get A by itself. So I'm going to rewrite it as measure of A is equal to that 180 degrees because we subtracted measure B and C from both sides. Well, we know what the measure of B is. It's 49 degrees. We know the measure of C, which is 63 degrees. And when I subtract all of these, it gives me a measure of 68 degrees. So now I know the measure of A. So now we can find the area of the property. We're going to use the formulas at the beginning that was given to us. And it's the sine of the ratio of sines, okay? So it is given that C is 480 degrees, or excuse me, 480 feet, right? That was given to us. Since we're finding the area that requires two sides of the triangle, let's use the sine, the law of sines. So I'm looking for a little a. I got sine of capital A is equal to little c of sine of big C. And what I'm going to do is solve for A. So in order to solve for A, I need to multiply by this denominator here to undo the fraction. So I'm going to rewrite this. So I got A is equal to C sine of capital A divided by sine of capital C. And we're going to plug in what we know. And what am I calling capital C and capital A? I'm calling the measures. The measures. See it? That's what I'm calling. All right. Well, we already know what A and B and C is now as far as the measures go. And I'm going to plug in what I know. So little c is 480 feet, sine of 68 degrees divided by sine of 63 degrees. And when we type this in our calculator, we're not gonna round right now. And if you do, don't round very much because this is not our final answer. We want to round on our final answer. So I got approximately this for A, and I'm going to use it in my area formula and then round my final answer. So now I got the formula of A is equal to my half AC sine of my beta. And we can double check just to make sure if you're ever in doubt on the formula we picked. So AC, yeah, is beta. All right. So now A, we found A and we know what C is, and I'm gonna plug in what I know. A is 499.489, and we're gonna multiply it to my C, which is 480. And then we got sine and of my beta, and my beta is 49 degrees. This is this one here. Type that in our calculator, and we come out with 90473 rounded to the nearest feet. That's going to be feet squared. And that is my answer.